Hey guys, it's Miss M here. Um, I miss all of you so much. I think it's really funny that in class this year we had a joke about having a YouTube channel, and we always said like and subscribe after lessons, and now look at us. We have an actual YouTube channel. I miss you guys so much. I miss teaching. I hope all of you are okay. Um, Try to stay sane during this time. Get some fresh air, get some sunlight. Um, until we are able to go back to school, this is how I'm going to be posting lessons for you guys. If you don't have the textbook, please don't try and screenshot the video or anything like that. I'll be posting pictures of the textbook online on the D6. Now, if you don't have the D6, this is going to be a problem because all my communication is done on there. Please tell your parents to get the app, and if you're having difficulties getting the app, you can also log in online. Please, that's very important. So we're going to be talking about metals and non-metals in this video. Now, this is a very interesting section. I absolutely love this section. We started last week talking about activity 1, and we did a little basic introduction in our Platinum Natural Science textbook on page 61. I'm going to be making notes as we go along. I ask you guys to please, in the next 2 pages of your natural science notebooks, the next 2 clean pages, unused, I want you to make notes from this video. Now, if some of you guys have data issues, that's absolutely fine. Download the video offline. So on YouTube, there's an option to say save the video. Try and save the video so that if you need to go back and make notes or pause it, then you're not wasting your parents' data if you don't have Wi-Fi, or you're not wasting the Wi-Fi. Yeah, so download it offline so you can watch it whenever you want. You can watch it maybe more than once if there's some things you didn't catch on. There's going to be a lot of new terminology and a lot of new explanations and new content in this video. This is stuff we haven't done yet. So yeah, it's very exciting. I'm excited to be teaching again for the first time in a while. Thank you guys for emailing me. Your emails are really keeping me going. And yeah, let's get going. Let's use this time wisely during the lockdown. I know we're all trying to stay sane and happy and just try and survive, but at the same time, do something for yourself now that your future self will thank you for, because once we go back to school, things are going to be very difficult. So rather keep on track with the work now, and when you go back to school, you understand all of this and you know all this work. Okay, that's enough chit chat. Let's get cracking. Now we're talking about metals and non-metals. Before we start any of this, some of you might be wondering, why do we categorize all things under the categories of metals and non-metals? Why those categories? Well, here's why. It's because of the special properties or characteristics of metals and non-metals. Now, some of you might be thinking, oh my god, I don't understand what that means. I'm going to explain everything. It'll be fine. Okay, now let's just look at this picture. This is an interesting picture. It's interesting because it's showing us all kinds of products that are made from different materials. If we look here, that's showing us a plastic milk container. We have a soccer ball, we have some socks, we have a glass jar, like one of those jars that Nutella comes inside. We have a Pocky pot, we have a tin can, a wooden spoon, elastic bands, a mug, a metal spade, I'm assuming that's metal, it looks metal to me, a clay vase, plastic gloves, and this is a basket. It's woven. Okay. Now, let's talk about these. Why do we divide all of these into metals and non-metals? That's because all the metal products here have the same properties or the same characteristics. Let that sink in. Everything that is not metal is different because of different characteristics. For example, if we look at this this glass cup and this glass jar, both of these are non-metals. They're classified as non-metals because they are not metal. If we drop them, they will break. Okay, if we drop them, they will break. How do they feel under our fingers? These are the properties. How does a glass cup feel under your fingers? It feels soft, smooth. It feels cool sometimes. It's reflective. I wouldn't say it's shiny, but it's reflective. It has a reflective surface. It is also able to shatter. So if we drop it on the floor, it will shatter and break. Now, let's compare these two, to the tin can. Now, this is metal. This can of Coke, the outside of it is metal. The inside is Coke, obviously. So this is metal. If we drop the can, an empty can, on the floor, it probably won't break. It might be dented slightly, but it won't break. It is shiny because it's a really nice metallic color. Metals are mostly metallic unless they are coated by something else. For example, this tin can is metal. It doesn't come in red. We just coat it in red. We cover it to make it look cool. It is usually a shiny color, a silver color. It's shiny. That's one of its properties, is that it's shiny or it has luster. We say that it has luster because in science, remember, we're not kids anymore, we're scientists. So we don't say, oh, this tin can is shiny. No, we say that it has luster. I'll write it down for you just now and then you can see how to spell it. Now, if we talk about these versus this, it will be non-metals versus metals. This also, if I take a hammer and I start beating this tin can, and if I start beating it from the top, like this, I am able to hammer it into a little disc. That is also another interesting property of metals that we're going to be talking about. Now, if I take that same hammer and if I beat this jar and I hammer this jar in a downwards direction, it will break. It will definitely break. So that is how these are different. Their properties are different. If I take my hammer and if I beat the soccer ball, probably nothing will happen. It will just bounce. If I take the same hammer and I beat these socks, nothing will happen. If I beat this wooden spoon, nothing will happen. But what's interesting is that this metal tin can is able to be hammered into a flat little disc if I am strong enough, which most of you know I am not. Okay, that was a little tiny introduction to the difference between metals and non-metals. I asked you guys to summarize the properties of metals last week, so you should have done that. If you didn't, do it. Pause the video and go do it. You should have done it. Now, this is very interesting. But before we get into the properties of metals, we have to talk about some of the keywords because we cannot go into a new section without knowing our keywords. So let's start. What was that? Oh, that was my lid. Okay, so my first keyword is the word properties. I'm filming with one hand and writing with another. Okay, so bear with me here. Metals and non-metals. So our first keyword is properties. Now, properties are the characteristics of something. The second keyword that we're going to talk about, that I already mentioned, is luster. If something is shiny, we say that it has luster because that is the correct professional term to use in science because we're scientists. Remember last term we spoke about a hypothesis and a guess? A guess is the exact same thing as a hypothesis, but the hypothesis is the cool science-y version of that, the terminology. And it's important to use the correct terminology because we are scientists. Great. The third one. If something is hard, and if I say, grade 5, tell me the properties of a block of wood. You guys, instead of saying it's hard, you can say it's rigid. That is the correct terminology to use. So if something feels hard to touch, for example, my desk is, I've got some paint on it. Just ignore that. You guys know how I paint. This is my desk. It's wooden. If I knock it, it's rigid. It's hard. It's hard. It's not gonna break. It's not like paper that if I knock it, it'll break or tear. It's not like slime. If I knock on slime, it'll probably deflate a little and bend and be all squishy. But this is wood. This is rigid. It's hard. Does it have luster? Does my desk have luster? No. Therefore, if we say this desk does not have luster, that means that that's a property it doesn't have. It's not shiny. It doesn't have luster. Okay, another one. I know this is a lot to take in, but try and keep up with me. Try and stay on board. Put on your thinking caps. I know it's been a while. Okay, another one is malleable. Now, malleable is a fancy word, a sciencey word that we use to describe when we can hammer something into shapes. Remember I told you guys if I took a hammer and I beat a tin can, I could probably make it become a really nice little round disc like that, a flat one. That is because it is malleable, able to be beaten or hammered into shapes. Okay, we're doing really well so far. Pause the video if you need to breathe or drink some water. It's only 12 minutes in though. I think we're doing quite well. Okay. Alloy. This is a lovely one. This is my favorite. My favorite keyword. An alloy is a mixture. It's not focusing. An alloy is a mixture of two or more metals. Now, some of you, when you walk around the stores and you go to the mall or Gateway or whatever, you see these shops that are called Touch of Gold. Have you guys seen those? In those stores, they have alloys or they have a brass or a silver ring that is coated in a thin layer of gold to make it look gold. There are advantages and disadvantages to this. It's not right or wrong. It's just how it's just jewelry, but it is coated in something else. For example, a 5 Rand coin. I want you guys to go and Google what it's made of, what is coated in, the new 5 Rand. So alloys are a mixture of two or more metals. Now, some of you might be thinking, why would we mix metals together? Well, there are many different kinds of metals, like we're going to discuss on page 63. There are many different kinds of metals, and all the different metals have different, very unique properties. Just like how all of us in class, like the 30 of us, are all unique, and we all have different strengths, all the metals are different and unique and have special strengths. For example, what's very interesting is that gold is the only metal that does not tarnish. Maybe we should put tarnish down here. Tarnish means to lose its color or rust. Not rust, it's almost like a mild version of rusting. To tarnish is to lose its color or go dull. Gold, I'll just repeat that for you. Gold is the only metal that does not lose its color. It can over time become a little slightly duller, but that is just, you can always just get one of those cloths that you can use to shine it and it'll become brand new again. Other metals rust, and they, for example, iron is a metal that rusts, and it rusts so badly that it corrodes and flakes off and becomes dust. Iron is very, very rusty. It rusts very, very easily. Now, if you live near a very humid area, or for example, if you live near the beach, you'll notice that anything that is not plated and is metal outside, for example, fences and things like that, they will all rust because the moisture or the salt in the air makes the metal rust, especially in humid areas. You'll notice sometimes if you put metals outside for a while, like those live, laugh, love signs. I have one outside my house, and it just rusted so badly. It's because of the humidity and the moisture in the air. Okay, let's get cracking. Let's carry on. So let's read through this page together. It says, many things we use in everyday life are made from metal. We use metals to make things because they have certain useful properties. The property of a material refers to the qualities of matter and material. Some of the useful properties of metals are listed below. Okay, I'm going to start making notes. Let me use my fancy purple pen. So, now this is very important. I asked you to summarize this last week. Properties of metals. Important. I will test you on this in tests and exams. Okay, before we start the properties of metals, let's talk about metals. What are they? Metals are materials that are found underground in rocks that we call ore. Remember that. For example, iron is found in iron ore underground. Copper is found in copper ore. Silver is found in silver ore. Ore is the rocks that the metals are found in underground. You should know that. Okay, now let's talk about the properties of metals, or the characteristics of metal things. It's really easy. Number one, this is not something that you need to understand. This is something that you need to study and remember. It's like your times tables. Do you need to understand it? No, you just need to study it and know it. That's the same thing with this. There's only 6 points. Know it. Number one, they are strong. Metal objects are strong. If we drop them, they will not break, although they might bend. That's because of that really cool property called being malleable, able to be beaten or hammered into shapes. The second one, most metals are very hard, but a few, like pure gold, are much softer. Okay, so some of them are hard. Number 3, metals are shiny or they have luster. I'm going to put shiny here. Usually when I talk to you about this when we go back to school, I'm not going to say shiny because that's childish. They have luster. Number 4, they are malleable. See here, malleable, able to be beaten or hammered into shapes. You should know that. Come on, guys. Number 5, they are ductile. Now, ductile means that metals are able to be pulled into wires. Now, if we look at our wires, most of our wires are made of copper, and these are electric wires, and they are used because they conduct heat or electricity very well. But if something is ductile, it means that it is able to be pulled or drawn into wires. Okay. Now, please don't be confused by this. Ductile just means that we are able to pull these metal materials into long, thin wires. Now, can we do that with wood? Can we ever use a machine and pull wood until it becomes thin, long wires? No. That's why it's a non-metal. It has non-metal properties. It can't do this cool thing. Only metals can do these 6 cool things. Okay. Now, number 6. Metals melt at high temperature. This means that we can use metal pots for cooking without damaging the pots because that is not such a high temperature. We use metal pots for cooking because they conduct heat very well. For example, imagine we are trying to cook in a plastic pot. That won't work because plastic melts at low temperatures and our food would all become toxic and our pot would just melt and be unusable. Can we cook on a wooden pot? No, because wood does not conduct heat as well as metal. If anything, wood would catch alight, I would assume. Okay, so number 6, metals melt at high temperatures. Metals melt at high temperatures. Now is the time to take a screenshot if you want to. If you're lazy. But don't copy mine, I'm checking. Okay, these are the 6 properties of metals. They're very cool. Now let's take some time to highlight them, go over them. Number 1, they are strong. Number 2, they are hard. What's the cool word for hard? Rigid. Number 3, they have luster. If I say, for example, ooh, guys, your hair looks lustrous, it means it looks all shiny and healthy. Luster. Number 4, it's malleable. What does malleable mean again? It means that it is able to be beaten or hammered into shapes. Now, do not confuse being soft with being malleable. I can hammer press stick into shapes, but it doesn't mean it's going to hold that shape. Remember that. Just because press stick or slime is soft, and if I hammer it, it will bend, it doesn't mean that it is malleable. Metals are malleable because I can beat it into shape and it will hold that shape. It will stay in that shape. Number 5, ductile. That means it is able to be pulled or drawn into wires. And the last one, number 6, metals melt at high temperatures. This is like the alphabet. You need to study this and you need to know it. It's important. What else do you have to do? Come on, guys. When we go back to class, I want to test you and I want you guys to know it. Okay, see how easy that was? Properties of metals, all 6 done. That was fun. Okay. Now, let's look at activity 2. It says identify the properties of metals. So look at figures 2 to 7 and answer the following questions. Okay. Here's figure 2 at the bottom. Tools need to be hard. Okay, they're talking about things like hammers and screwdrivers. And if you look here, it's very small. It's very small, but it's a craft knife. Then we have a screwdriver, we have a hammer, we have a paintbrush, another screwdriver, and we have I forgot what that's called. Pliers, yes. Sorry, pliers. These all need to be hard because if we are going to be using these tools to change or improve things around the house or anything, they need to be able to withstand a lot of pressure. So number 1 says, which of the objects may have been hammered into its shape? They are talking about here, figure 3, 4, 5, and 6. So figure 3 is a silver ring. I'm not going to do this with you because I want you to answer this into your book this week for your science work, and then I will post the memo on Monday. So that gives you exactly a week to finish this work. An aluminium foil tray. Remember, an aluminium foil tray is a metal. The properties of metals that we just did means the 6 things that every single metal out there can do. So an aluminium metal foil tray, can it be hammered into shape? I wonder. Stay tuned to find out. Figure 5, a toy car made with wire, and figure 6, molten iron. Molten means that it is at such a high temperature that it has melted. You can look at it in the picture. And if you don't have your textbook, it's fine. I'll post pictures on the D6. Relax. Now let's look at number 2. Which of the objects is made from a very thin sheet of metal? Ooh, that's easy. Number 3, which of the objects has been made because it is shiny and looks good? Ooh, interesting. Very easy as well. Guys, these are not trick questions, okay? These are easy. Write down the names of 2 different objects that would not work if they were not made of metal. You may not name any of the objects figures 1 to 6. So what they're asking you is, they're asking you to think of a few different objects that wouldn't work if they were not made of metal. So if something that is made of metal is made from a different material, would it still work? Now I'm going to give you a few examples. Don't use my examples. Make your own. For example, a pot. Okay, a saucepan on the stove. It is made of metal. Now if it was made of any other material, would it still work? My answer is no, not really. Like the Poiki pot is made of clay. I understand that. So maybe clay, yeah. But if it was made of absolutely anything else, it would not work. Even clay itself, we cannot put on the stove. We have to light a fire underneath it in order for the heat to cook the food. So, technically speaking, if a pot is made of absolutely any other material, it would not work. If a pot was made of paper or wood, would it work? No. If it was made of plastic, would it work? Absolutely not. If it was made of horse hair, would it work? No. If it was made of cow skin, would it work? No. If it was made of glass, would it work? No. If it was made of wool, absolutely not. Come on, guys. Okay, I want you to get your own examples and write it down for number 4. Okay. Now, page 63. I think when we're done with page 63, I'm going to stop there. And then I want you guys to make those 2 pages of notes and answer activity 2. I'm going to go through this page with you and then I'm going to stop, because I feel like that's enough. Okay, some common metals and their special properties. Ooh, I love this part. Just adjust my light. Okay, there we go. Some common metals and their special properties. Can you guys see that? Okay, that's better. Some common metals and their special properties. What is that? Iron is a metal that has been used by humans in Africa for a very long time. It is used to make objects such as tools, nails, fence posts, wire fencing, and weapons because it is strong and hard. This feels like a table. Okay, we have a table now. So it says some common metals and their special properties. Okay, so I'm going to say on this side, metals, and on the other side, is it focusing? Their special properties. Remember I told you earlier that all of us have our own strengths and weaknesses? Well, metals are the same. They have their own unique strengths and weaknesses. It's a lot of fun. It's very interesting. So the first one we're going to talk about is iron. And it says that we use it to make tools, and they are strong and hard. Come on, guys. What's the key word for hard? Rigid. Yay. Okay. It says a problem with iron is that it rusts. Oh no. Okay, let's say disadvantage, rusts. So the advantage is that it is strong and rigid. The disadvantage is that it rusts easily. Nice. I wish my table looked better. Number 2, gold. I love gold. Gold is a valuable metal. It is very malleable. So it is easily worked into jewelry. It always shines and never goes dull, so it makes pretty jewelry. The people of Mapungubwe used gold sheets to make precious objects very long ago. So gold, number 2 is gold. The advantage, or why we use it, is that it is valuable. Remember that cool fact I told you earlier? Does not tarnish. Valuable, does not tarnish, and it is also a softer metal. Obviously not as soft as slime or Prestic, but it is slightly softer than others like iron and copper. Valuable, does not tarnish, and it is softer. Okay, now can you guys think of a disadvantage? Can you think of a disadvantage to gold? I don't know. I would say that being valuable or expensive is a disadvantage, because if you lose it, you'll get sad. So a disadvantage is that it is so valuable. I could go both ways, I guess. Number 3. Silver is another valuable metal which has been used for about 8,000 years. Wow. So if we're in 2020 now, imagine 6,000 years before us. It shines brightly and it is also popular for making jewelry. Yep, a lot of us have silver jewelry as well. It's beautiful, just depends on your preferences. So again, it is special because it's valuable. It is very malleable. Another softer metal like gold, so it is very malleable. Malleable, say it, malleable. Used for making jewelry. I forgot to write that under gold. Used for making jewelry. Your notes should look like this. I don't mind if it's messy. Valuable, very malleable, and it is used for making jewelry. There's 2 spellings to jewelry. It's Jewellery or this way. Can you think of a disadvantage? I can't. Copper, number 4. Do you see how this page of text versus a table is so much easier to study? Do you see that? Okay, copper is another metal that has been used since about 6,000 BC to make ornaments and weapons. It conducts electricity very well and is used for electric wires. What was that thing we spoke about copper? Copper also rusts very easily. So copper has been used since about 6,000 BC to make ornaments and weapons. Ornaments, weapons, and electric wires. Conducts heat and electricity very well. Now later on in this section, we're going to be talking about how we protect copper wires from becoming rusty. We usually coat them in a thin layer of plastic. Now sometimes, oh, there's a nice picture here. That's a nice little plastic coating, and it's covered in different colors, and different colors mean different things. And here you can see the wire coming through. Okay, so after copper, we're going to talk about aluminium. Aluminium is a very light but strong metal. It is used in aircraft construction. There's more aluminium in the earth than any other metal. Interesting. Now, when we make a table like this, a summary table, we only add important, absolutely essential information. Okay, so we don't have to say there's more aluminium in the earth than any other metal, because I feel like that's a fun fact. Aluminium. Okay, it is light, strong. Now, it says that it is light and strong and it's used in aircraft construction. Can you see how those advantages are related? Would we want to be using a very heavy metal in an aircraft? This is the part where I wish you guys were here so you could answer me. We use light metals in an aircraft because an aircraft needs to be as light as possible. If it's really heavy, then obviously it's going to be difficult for the airplane because it's in the air. So aluminium is light and strong, and it is used in aircraft construction. And the last one, zinc. Zinc is a metal that is used to cover iron so that the iron does not rust. Many water buckets are made of iron but coated with zinc. Zinc is a metal, eh? Remember that. So zinc coats iron to prevent rust. Okay, I think I'm going to stop there for today. Take a second and screenshot this if you want. Remember, you have to do, so the work you have to do for science for me is, you have to read through page 61, 62, and 63 again. Then you are going to be doing 2 pages. Remember, I said 2 pages in your science notebook on just a summary of what I've done. For example, I've done around 2 pages. Then maybe I want you to fill the entire 2 pages though. So maybe you can draw diagrams. You also have to finish the activity 2 over here, identify the properties of metal. So you have to finish this activity as well. Remember, don't stress if you don't have your textbook. I'm posting pictures of it on the D6 like now. This video is long enough. Hopefully maybe the next video, part 2, will be a bit shorter because I know you guys have data issues. I miss you guys so much. Try and stay happy and stay calm. Study this work if you're bored. And I know that it's difficult to be at home right now, and even me, I'm finding it kind of difficult to just be indoors all the time when we're so used to having such long days. Try and not stress your parents out too much. A lot of them are still working from home, so help out. And yeah, just stay happy and healthy, and I miss you guys. And like and subscribe. See you in the next video.